In this video, we're going to look at integrating 1 over x. So if we integrate 1 over x, we're going to look at it as a reverse process of differentiation. So we remember from differentiation, if you differentiate y is equal to ln of x, you get dy by dx is equal to 1 over x. Therefore, if you reverse that and you integrate 1 over x, you will get ln of x. So the result is this: if you integrate 1 over x with respect to x, you get ln of modulus of x. Now, where this modulus comes from, or why this modulus is necessary, is that ln functions or log functions are undefined for negative x. So you'll see this whenever you have limits in place. Whenever it's a definite integral, you need to make sure it's a modulus. So it doesn't happen to come up very often in exams, to be honest, but strictly when you integrate 1 over x, you should have the ln of a modulus function of x plus your constant of integration. Okay, also we have seen if you have y is equal to ln of a function of x, then your dy by dx is equal to your function of x in the denominator and the derivative of your function f dash of x on the top on the numerator. So that means you reverse that process and you integrate f dash of x over f of x. Integrate that with respect to x, you will get ln of modulus of f of x. And again, the modulus is necessary in case at any point it is negative in here. So that's our result. Okay, so if we think about this one, what we want to do is look for the presence of a function and its derivative on the numerator. And if it's not in that form, you have to play around with it a wee bit. So here we've got a nice one. You've got x squared plus 4 in the denominator. And if you differentiate x squared plus 4, you get 2x. So that means we are in this form, f dash of x over f of x. That means if you integrate, you just get ln of x squared plus 4, modulus of x squared plus 4 plus c. Now, this is an interesting one here. It's unnecessary to have the modulus sign. The reason it's unnecessary is plus 4 is always positive. And even if you had a negative number squared gives you positive. So you'll have positive plus positive. So here, in this case, we don't even need to write the modulus, but you're not going to lose your marks for having your modulus sign in here, so we've just left it. Okay, we're going to look at a few examples now on these. The first example is dead easy. It says integrate 2x. I'll change the pen here. Integrate 2x minus 1 over x. So for this one, integrating with 2x is dead easy. Integrating with 2x is dead easy. 2x integrated just becomes 2x squared over 2, which is just x squared. Integrating the 1 over x, remember, was ln, integrated was ln of modulus of x. And then remember, and you would lose marks if you forgot it, your constant of integration, c. Okay, this second one. Now, we want to try and get in the form, remember, f dash of x over f of x integrated with respect to x. That's what the form that we want to get this in. It is not currently in that form because if you integrate 1 plus 2x, if you differentiate 1 plus 2x, you will get 2. So we're not currently in that form. So what I'm going to do is just change it so that it is in that form. So I'm going to leave the 1 plus 2x on the bottom line, but the top line, if I differentiated my bottom line, I would get 2. So I'm just going to write it like that. And clearly, this line is not the same as this line, but what I can do then is pull a half outside. So if you pull a half outside, then we're good to go. So we're now in our form over here, we're now in the form f dash of x over f of x. So we can integrate that thing. So you're just going to have the half times your ln of modulus of 1 plus 2x, close your modulus sign, plus c, and that's it. Okay, next example, just check. Differentiate this bottom line. Differentiate 4, you get 0. Differentiate 3x squared. 3x squared, you get 6x. So happy days, we're actually in this form over here, so we're good to go. We can just say this is just going to be equal to ln of modulus 4 plus 3x squared plus c. And in this case, like the one we talked about earlier, we don't need the modulus sign because the 4 and the plus 3x squared are always going to be positive, so you can get rid of the modulus sign. So I'll just write in here, modulus not needed, as always positive. Okay, so I've just written modulus not needed, as always positive. Okay, on to our example 4. Now in this one, what we need to do first is just divide through by the x and see what this is, or even write this as two separate terms. So we're just going to write this as going to be separated out. So I haven't integrated. X cubed divided by x is just going to be x squared, and then minus, and that's going to be 1 over x dx. And now you're good to integrate. If you integrate the x squared, you're going to get x cubed over 3. Integrate 1 over x, you'll have ln of modulus of x, and then plus your constant of integration, and that's it done. Okay, example 5, we have got the same order on the top line as in the bottom line. So remember, we'd seen this when we looked at our partial fractions. If the order of the numerator was the same or greater than or equal to the order of the denominator, you must first divide. Nothing has changed here. We need to do that as well. So I'm just going to say need to divide first. So before you do anything, you've got to divide. So I'm dividing my x, and I'm dividing it by x plus 3. So a lot of people get that the wrong way around. Remember, the x plus 3 is on the denominator, so it's the thing it's dividing, so it's your divider over here. Okay, x goes into itself one time, so I'll put my 1 here. And then 1 times the x plus 3 gives you x plus 3. So just write down your x plus 3 underneath. And then what you're doing is you're doing this line minus this line. So you have 0 minus 3, which is minus 3, and x minus x, which is 0. So that just took us down to minus 3. So what we have shown then, our integral becomes, sorry, I'll write it again, what it was, x integral of x over x plus 3. So it is now going to become the integral of 1 and then minus 3 over x plus 3 dx. Okay, if you integrate that, then what you'll get, integrate 1, you're just going to get x. And then this really, the bottom line differentiated should give you 1. So you've actually got a 3, or technically a minus 3. So really it is just minus 3 upon ln of modulus x plus 3, and plus your constant of integration. Okay, very important to be example for us to see. This is a definite integral here, and it says give exact answers, and we'll have to talk about what that means here. First thing we've got to do is a wee bit of tidying up before we can do anything here. I'm just going to write this again. Still, I haven't integrated, I'm just changing how it looks a wee bit. I'm going to write this as a half upon 1 over x, and then plus, and that's me 4x to the minus 2. So now we're good to integrate. So I'm going to use my square brackets from now on. So 1 over x integrated just give you ln of modulus of x. And you've got a half multiplying that, so that's just a half upon ln of modulus of x. And then if you raise the power of this by 1, it'll go up to minus 1, and divide by the new power, you're going to have minus 4x to the minus 1. And I'm just going to leave it as that for the time being. And then we're going to put in your limits are 9 and 4. So you're going to have 2 square brackets here. And the first one, you're going to put in your x is equal to 9. And the second bracket, you're going to put your x is equal to 4. So first one, you're going to have a half ln of 9. Notice I got rid of the modulus there because 9 is already positive, so we're good. And then it's going to be 4 to the power of minus 9, which is, sorry, minus 4 times x to the power of, so that again, it is minus 4 times 9 to the power of minus 1, which is going to be minus 4 over 9. And over here, it's going to be a half ln of 4, and then minus, and it's going to be 4 over 4. Okay, that's an absolute mess, so we'll tidy it up. So I'm just going to separate these two examples. Apologies. Separate these two examples. I've got a half ln 9 minus a half ln 4, and I've also got minus 4 over 9 minus 4 over 4, which is going to be equal to, so that's, sorry, minus 4 over 9 minus 1, so that's minus 4 over 9 plus 1. Do that in your calculator if you need to. That's going to be plus 5 over 9. Okay, another, apologies there, phone rang. And so here, tidy this up, you've got a half upon ln 9 minus a half ln 4. So that really is a half upon ln, sorry, I'll do that in bracket, ln of 9 minus ln of 4, and then plus your 5 over 9. So this is your second rule of logs. Log of a minus log of b is log of a over b. So you can write this as ln of 9 over 4. So that's really a half ln 9 over 4, and then plus 5 over 9. And also this half can, this is your third rule of logs, which is n log a is equal to log a to the power of n. So this half can go up here, and that means it's 9 over 4 to the power of a half, which means the square root, so I'll write that, that's 9 over 4 to the power of a half, which means the square root of 9 over 4, which is 3 over 2. So this thing we can write, our last bit, you can write this as ln of 3 over 2 plus 5 over 9. And if you have a wee look at this, this is an exact perfect answer. So we haven't rounded to any decimal places. This is exactly what you want. Okay, you're now ready to do, it's topic 7. Topic 7, exercise 3, from your question booklet.